Hi guys, so this is the first video on Math SL differentiation, chain and product rules. In this video we shall tackle these 4 questions and they shall mainly revolve around the very basic application of the chain rule. So these are the elementary questions under this topic, and I shall begin question 1 shortly. So question 1 came in paper 1 May 99, question number 17. Kindly take a minute to pause the video, attempt to solve, and the answer shall follow through shortly. So for question A, we are required to differentiate with respect to x the function root 3 minus 4x. So you should be familiar with the basics and the essentials of differentiation, where we multiply by the old power and reduce the power by 1 and so on before you attempt to solve chain rule questions, and you should consult a textbook if you don't know how to do that yet. For the purpose of this question, we shall rewrite the function in this green format. So instead of root 3 minus 4x, I shall rewrite it as 3 minus 4x to the power of half. Note that I have not differentiated yet. The green function is still y equals something. Starting from the blue function, I'm dealing with y dash. So this is the derivative function. So make sure that you can distinguish between y and y dash. Now, the basics of the chain rule are as follows. You differentiate the outer function first using the regular rules of differentiation, and this is what we shall do now. We shall multiply by the old power. So the old power is half, so I took a half outside, and it shall multiply my entire expression. Then we shall reduce the power by 1. So half minus 1 gives me negative half. So far, we're dealing with regular differentiation. So how is the chain rule different? Only that there is an outer function and an inner function that is actually differentiable. So the box that I've differentiated is 3 minus 4x. I've treated this as a box. I've not looked at it yet. I've only multiplied by the old power and reduced the power by 1. So what remains for me to do is to differentiate the inner function, which is 3 minus 4x. What is the derivative of 3? Obviously 0, because it's a constant. What is the derivative of negative 4x? This becomes negative 4. In the red equation, all I've done is simplify. I've multiplied the negative 4 by the half, hence obtaining negative 2. And the bracket remains the same, 3 minus 4x to the power of negative half. So you should be aware that the root of anything can be rewritten as power half. I've added an extra example here that has nothing to do with the exam question, just for your extra awareness of the issue. So let's check this out. Given that y equals the fourth root of 2 minus 5x, how do I differentiate that? So let's repeat the procedure again. There is an inner function and an outer function. So first, I rewrite this as an exponent instead of a root. The fourth root becomes power 1 over 4. So I have not differentiated yet. The blue equation is still y and not y dash. Watch out. So y equals 2 minus 5x to the power of 1 over 4. I shall first treat 2 minus 5x as a box. I shall ignore it. I shall use the regular principles of differentiation. Multiply by the old power, so there is the 1 over 4 outside. Reduce the power by 1, so a quarter minus 1 or 1 over 4 minus 1 gives me negative 3 over 4. Then look at the inner function and differentiate. So 2 minus 5x, again the 2 differentiates to 0 because it's a constant, and the negative 5x becomes negative 5. And again, in the gold equation, I have only simplified. Basically, I multiplied negative 5 by 1 over 4 to get negative 5 over 4. So this concludes the extra example for question A. Now for question B, I'm required to differentiate y equals e to the power of sine x. Again, there is an inner function and an outer function. So to differentiate e to the power of something, e to the power of x differentiates to e to the power of x. So to differentiate e to the power of sine x, I simply write down e to the power of sine x. Then I go to the inner function, which is sine x, and differentiate that. So what is the derivative of sine x? Cosine x. So I multiply my answer by cosine x. So this concludes our first question in this video. Kindly take a minute, pause the video if you're going to copy this down, and I shall begin question 2 shortly. So the second question in this video came in paper 1, May 2003, question number 5. Kindly take a minute, pause the video, attempt to solve, and the answer shall follow through shortly. So I'm given this function in black, e to the power of x over 3 plus 5 cosine squared of x, and I am asked to differentiate. What I shall first do is rewrite the second term in a friendlier form that shall help me differentiate. Instead of cosine squared of x, because this might be confusing for some, I rewrote it as cosine x all squared. And these two expressions mean the same thing. Cosine squared of x and cosine x all squared. So the purple equation is not the derivative. It's just a rewriting of the question, which is in black. Now I'm going to start differentiating. We said in the previous question that e to the power of anything becomes the same exact term. So e to the power of x becomes e to the power of x. E to the power of 5x becomes e to the power of 5x. So e to the power of x over 3 becomes e to the power of x over 3. But I still need to differentiate the inner function, which is x over 3. So you simply differentiate the numerator, and the derivative of x is 1. So you multiply by 1 over 3. So the derivative of x over 3 is 1 over 3. If I have two terms separated by a plus or minus sign, I can treat them as independent problems. So I'm just going to differentiate e to the power of x over 3 alone, then add the plus sign, then differentiate the second term, 5 times cosine of x all squared. So to differentiate the second term, I shall follow the basic chain rule protocol, which is to multiply by the old power, which is 2. So I have an extra 2 here. This 5 is a constant, so it remains as it is. Cosine x all squared becomes cosine x to the power of 1, which is just cosine x. Then I go inside the inner function and differentiate. So what is the derivative of cosine x? It is negative sine x. Now the red expression is a perfectly fine final answer, but you can always rewrite it in a nicer format. So the first term becomes 1 over 3 e to the power of x over 3, and 2 times 5, and with a negative sign give me negative 10. sine x cosine x. So this concludes our second question in this video. Take a minute to pause the video and write this down if you will, and I shall begin question number 3 shortly. So question number 3 in this video came in paper 1, November 2004, question number 2. Kindly take a minute to pause the video, attempt to solve, and the answer shall follow through shortly. So we are asked to differentiate f of x equals 6 cubic root of x squared, which is the function in black. You shall notice that the first row of my solution does not contain any differentiation. It is entirely a rewriting of f of x. And the second row is where I have found and simplified my derivative. So watch out that sometimes you need to play around with your function first for a while before differentiating in order to simplify things for yourself. Now, 6 times cubic root of x squared. We have mentioned in the previous question, or the one before, excuse me, that the cubic root can be rewritten as something to the power of 1 over 3. The nth root can be rewritten as something to the power of 1 over n, whether second root or third root or fourth root and so on. So what I did in the blue equation is simply remove the root and write it as an exponent. To go from the blue to the red equations, I have simply utilized the property of multiplying exponents. So x to the power of 2 to the power of 1 over 3 is the same as x to the power of the two exponents multiplied by each other. So 2 times 1 over 3 gives me 2 over 3. I've multiplied the exponents by each other. Now, by doing these simplifications, I no longer even have a chain rule problem. I simply have a constant and a variable raised to an exponent. So this is basic differentiation. So I'm going to follow the same principles. I'm going to multiply by the old power. So I have 2 over 3 right there. The constant remains as it is. And I am going to reduce the power by 1. So 2 over 3 minus 1 gives me negative 1 over 3. So the new power is negative 1 over 3. And to go from the green equation to the purple equation, all I did was multiply the two constants by each other. 6 times 2 over 3 gives me 4, and hence my final expression is 4x to the power of negative 1 over 3. So take a minute to write this down if you will, and I shall begin question 4 shortly. So question number 4 came in paper 1, November 2005, question number 11. Kindly take a minute to pause the video, attempt to solve, and the answer shall follow through shortly. So in question A, I'm required to find f dash, where f of x equals 2x plus 7 all to the power of 3, available in black right there. So this is a simple chain rule problem. I'm going to multiply by the old power. So the 3 multiplies the expression. I'm going to reduce the old power by 1 to get the new power. So it becomes power 2. Then I'm going to go to the inside function and differentiate. So 2x gives me 2 plus 7, so 7 as an independent term differentiates to 0 because it's a constant. So I'm going to multiply my answer by 2, which is the derivative of 2x. Next, I'm going to simply simplify this equation. So 2 times 3 gives me 6, and the bracket remains as it is. Now, for b, I'm required to find g dash of x, where g of x equals cosine squared of 4x. So let's first rewrite this as we did before, as cosine 4x all to the power of 2. And let's apply the chain rule problem, but note here that I don't have an outer and inner functions only, I have 3 levels actually. So let's see how that works. I'm going to multiply by the old power, so I have the 2 outside, and cosine 4x becomes raised to the power of 1 because I've reduced my old power by 1. Next, I go to cosine 4x and attempt to differentiate. So what is the derivative of cosine 4x? The derivative of cosine anything is negative sine the same thing. So cosine of y becomes negative sine y. Cosine 4x becomes negative sine 4x. But I still have an innermost function, which is the 4x itself. Because if I only attempted to differentiate cosine y, so the answer shall be negative sine y, and there is nothing more to do. But cosine 4x is more complicated because 4x itself is differentiable. So the derivative of this 4x right there is 4. So I multiply my answer by 4. So here we have a 3-tiered chain rule problem. 3 levels. Now, to go from the blue equation to the purple equation, all I did was simplify a bit. I multiplied the constants by each other. I have a 2, I have a negative sign, and I have a 4, so I get negative 8 sine 4x cosine 4x. So this concludes our 4th question and our first video on chain and product rules. Take a minute to pause, copy this down if you will. I hope you have found this video beneficial.